going to work a few examples here from 7.1, just to kind of give you a flow of how to approach some of these problems. So I'm going to look at just a few. I'll start with number 7. You have k times k to the third. And so any variable that's just by itself has an understood 1 as an exponent. So although it's written a little bit differently, really it's the same as a k times a k to the third. So that's 1k times 3 more k's, so I have a total of 4 k's. I'm adding my exponents, again understanding that there's a 1 there in place if there's no number there. So my answer would be k to the fourth. Look at number 8. So here I have, again, notice that I have a base to a power times a base to a power. In that case, that's when I add my exponents. So that would be m to the sixth. Let's take a look at number 10. So number 10, the first thing I'm going to do when I see expressions with parentheses is I'm going to check and see, are there exponents outside the parentheses? If there are, I'm going to simplify those expressions first. If they're not, I'm just going to go ahead and start combining stuff. So I'm going to go in the order of negative signs is 1, and then 2 is going to be numbers, and then 3 variables. Sorry about the messy handwriting, but you get the idea. So I'm going in the order. I'm going to check negative signs, I'm going to check numbers, and then I'm going to work with my variables. So in this case, I don't have any negative signs, so I know my answer must be positive. So I'm going to deal with my numbers next. So I'm going to take my 3 times my 5, so 35. And then I'm going to deal with my variables. I'm going to go in order. I'm going to go take my u's first. I'll just take whatever's first here. So I have u to the fourth times u to the fourth, which is the same kind of idea happening here. Base to a power times base to a power. So that would be u to the eighth. And then I have v times v to the third, which is exactly the same kind of thing that happened here. So that would be a v to the fourth, because I have an understood 1 on this v right over here. Next we'll look at number 11. So this is dealing with the power to a power. Notice that I only have one base in the 3, and then that's being taken to the second again, and to the second again. And I'm not going to expand this out to show you, but remember the rule is that you multiply these exponents together. So 2 times 2 would be 4, times 2 again would be 8. So I would just leave this as 3 to the 8th. You could simplify it, but I'm just fine with you leaving it the way it is. Let's go to 14. So I'm going to look at 14. So again, I have this parenthesis thing happening here, so I'm going to check, is there a exponent outside the parentheses? And yes, there is. So I'm going to simplify. So what this means is that I have 3 of everything inside of here. So I have 3 negatives, I have 3 2's, I have 3 f squareds, I have 3 g to the thirds, and I have 3 h squareds. So we're going to deal with these one at a time again, dealing with negative signs first. I have 3 negative signs, that's odd. So I know my answer is going to be negative, so I'm just going to write a negative sign. Then next I deal with my numbers. So I have 2, but I have it taken to the third power, so I have 2 times 2 times 2, which is 8. And then I deal with my variables. So I have f squared to the third, which is the same kind of idea happening here. Notice there's only one f base. There's not another f to the third over here. This is f squared to the third, which is power to a power, which means I'm going to have f to the sixth. So f to the sixth. And then I have g to the third, which would be g to the ninth. And then I have h squared to the third, which would be h to the sixth. So that's how I'm going to deal with number 14. Now let's look at a couple questions here. that are just a little bit more in depth. Let's start with number 18. So again, if I have an expression that has parentheses or grouping symbols like brackets with a power outside, I'm going to deal with that first. So I'm going to just simplify this before even worrying about this. I think a lot of problems in exponent problems with students is that you just look at it and you seem to get overwhelmed by the information that's there. Just try and break it up into chunks and you'll find yourself managing things much easier. So I have a squared out here, which means I have two negatives, which means this expression is going to be positive. And then I look at my numbers, and I have two 3's, so 3 times 3 is 9, so this is going to simplify to 9. And then I have d squared, which would be d to the 4th. And then I have f cubed squared, which would be f to the 6th. And then I have g squared, so that would just be g squared. Now then, I have this other expression, so I'm going to deal with this. Now here, notice I have these two powers side by side, separated by grouping symbols. This is perfect power to a power scenario, so I'm going to combine these together by multiplying to get, I'll just write this down here, negative 3d squared f to the 6th. So I'm going to combine those together. So now I'm going to simplify this expression even further. So I have a 6 out here. That means I have 6 negatives. It means I have 6 3's. It means I have 6 d squareds and 6 f's. So we'll deal with this. So 6 negatives is a positive. 6 3's, that's 3 to the 6th. We can work that out later. And then I have d to the 12th. F to the 6th. So now I need to take this, and I need to take this, and I need to get them together. So if I calculate out what 3 to the 6th is, again, I'll think of that as 3 squared times 3 squared times 3 squared, which is 9 times 9 times 9. 9 times 9 is 81. 81 times 9, let's see, that's going to be 729. And then I guess I have to take that times 9 again. So I have a 1, 8, that's 6, 2, 63, 5, 6. So I have 6,561. So when I multiply, let's just refresh what I just did here. I multiplied 3 to the 6th, then I got 729. But now I'm combining these expressions, this one and this one. So I had to multiply 721 times 9, which gave me 6,561. So 6,561. Now I deal with my d's. I have d to the 4th times d to the 12th. Again, remember I have base to a power times base to a power. That's when I add. So that would be d to the 16th. And then I have f to the 6th times f to the 6th, which is f to the 12th. And then I have g squared. And that's what I get. So I took all this right here, and I worked it out to that right there, 6,561, d to the 16th, f to the 12th, g to the 2nd.